Hello everyone. In this lesson, we will discuss the overview of crude oil evaluation. The establishment of the petroleum refining industry can be traced back approximately to the 19th century. Crude oil fractionation units can be considered the prototype of refining processes. The invention of the internal combustion engine and the emergence of automobiles spurred the rapid development of the refining industry. By the mid-20th century, the refining industry had already evolved into a technologically advanced and large-scale sector. The petroleum refining industry is one of the most important pillar industries in the national economy. Its main petroleum products include fuels, lubricants, solvents, and chemical feedstocks, as well as petroleum asphalt, petroleum wax, and petroleum coke. Here we have a small question. In terms of consumption volume, which petroleum product has the largest usage? According to statistics, 40% of the world's required energy relies on petroleum products. The fuels used for vehicles and other means of transport are almost entirely petroleum products. Therefore, fuel is the petroleum product with the largest consumption volume. Additionally, organic chemical feedstocks also primarily originate from the petroleum refining industry. About 10% of the world's total petroleum output is used to produce organic chemical feedstock. To produce these chemical products, suitable processing schemes are essential. Determining the processing scheme for a crude oil is the primary task in refinery design and production. Based on the characteristics of the crude oil to be processed, product demand, the advancement of processing technology, production flexibility, economic benefits, and a substantial amount of data, comprehensive analysis, research, and comparison are conducted to arrive at a reasonable processing flow scheme. Therefore, crude oil evaluation must be performed. As one of the fundamental research tasks in the petroleum refining industry, crude oil evaluation involves a series of analyses, distillation, and other experiments on crude oil under laboratory conditions. This is done to understand the properties, composition, and classification of the crude oil, and to estimate the yield and quality of straight-run products, providing basic data for the petroleum refining process. Crude oil evaluation, based on different objectives, is broadly divided into three levels: general property analysis of crude oil, conventional evaluation, and comprehensive evaluation. Depending on the specific purpose and needs, different evaluation contents and items can be selected. The specific items are as follows. First is the general property analysis of crude oil. The general property analysis of crude oil includes first determining the water content, salt content, and mechanical impurities. If the water content of the crude oil is greater than 0.5%, dehydration is required first. After dehydration, the crude oil's density, viscosity, pour point, flash point, carbon residue, ash content, resin content, wax content, average molecular weight, elemental analysis, trace metals, and distillation range, etc., are determined. In this part, we can look at two tables. The first is a data table of the general properties of major Chinese crude oils. The parameters include density, kinematic viscosity, pour point, sodium content, light wax, asphaltene content, carbon residue, ash content, sulfur content, and other indicators. The second is a data table of the general properties of some foreign crude oils. The various parameters of crude oils from different regions vary significantly. These data have an important impact on subsequent oil processing. It must be emphasized that when measuring data, we must be truthful and accurate, which corresponds to what we usually call the craftsman's spirit and a serious, responsible work attitude. From the general property analysis of crude oil, compared with foreign crude oils, the main crude oils from China's major oil regions have the following characteristics. First, high pour point and high wax content. Second, low asphaltene content. Third, relative density is mostly between 0.85 to 0.95. belonging to relatively heavy conventional crude oils. Second is conventional evaluation. Dehydrated crude oil is distilled using true boiling point distillation and cut into narrow fractions, obtaining distillation data. The fractional composition of the crude oil and the physical properties of the narrow fractions are analyzed. The density, viscosity, pour point, aniline point, acidity, refractive index, sulfur content, etc. of each narrow fraction are measured, and the characterization factor, viscosity index, and structural group composition are calculated. The data are presented in the form of tables and graphs. Based on the differences in component boiling points, the crude oil is cut into several fractions. These fractions are often given names of petroleum products like gasoline, kerosene, and diesel. However, a fraction is not yet a petroleum product. To meet product specifications, the fraction often requires further processing to become a petroleum product. For example, fractions below 200 degrees Celsius are called gasoline fractions or naphtha fractions. 200 to 350 degrees Celsius fractions are called kerosene diesel fractions or atmospheric gas oil. 350 degrees Celsius to 500 degrees Celsius fractions are called lubricating oil fractions or vacuum gas oil. Fractions above 500 degrees Celsius are called vacuum residue. The oil remaining after atmospheric and vacuum distillation with a boiling point above 350 degrees Celsius is called atmospheric residue or atmospheric heavy oil. Third is comprehensive evaluation, which includes the following contents. Cutting and analysis of straight-run products. To rationally propose a crude oil cutting scheme, the crude oil is proportionally blended or recut in the laboratory into various fractions like gasoline, kerosene, diesel, reforming feedstock, and cracking feedstock, etc. The main properties of the products are analyzed according to product specification requirements. Various physical properties of the heavy oil and residue at different extraction depths are measured. For vacuum residue, penetration, ductility, softening point, etc. also need to be determined. Composition analysis of gasoline, kerosene, diesel, and feedstocks for reforming, cracking, and catalytic cracking. Analysis of the potential content and properties of lubricating oil, paraffin wax, and microcrystalline wax. Determining the equilibrium flash vaporization data of the crude oil, creating the relationship curve between equilibrium flash vaporization rate and temperature. Single hydrocarbon composition analysis of petroleum fraction. Looking at the chemical composition, petroleum mainly contains two major types of substances, hydrocarbons and non-hydrocarbons. Hydrocarbons and non-hydrocarbons exist in various fractions of petroleum. Depending on the origin and type of petroleum, the content of hydrocarbons and non-hydrocarbons varies greatly. However, in the same crude oil, as the fraction boiling point increases, the hydrocarbon content decreases, while the non-hydrocarbon content gradually increases. The hydrocarbons in petroleum mainly consist of alkanes, cycloalkanes, and aromatics, as well as mixed hydrocarbons that sometimes contain structures of all three types. From the results of crude oil evaluation, the characteristics of China's main crude oils are high wax content, high pour point, low sulfur content, very low arsenic content, and medium levels of nickel and nitrogen content. Some oil fields in Xinjiang and the east regions produce a portion of low pour point crude oil. In China's Daqing, Xingli, and Rinqiu crude oils, the gasoline component, gasoline fraction, is relatively low, while residue accounts for more than one-third. Waxy crude oil is suitable for producing high-quality lamp kerosene and diesel. Heavy gas oil is a good feedstock for catalytic cracking. From Daqing crude oil, lubricant base oil with a high viscosity index can be produced. Alright, that's all for this lesson. Goodbye, see you in the next class.